Assalamualaikum. Hello and a very good day I bid to all of the listener and the viewer of this video. Today, we, Group 1, will be presenting about the hydraulic jump experiment. These group members consist of Muhammad Azim bin Shahruddin, Muhammad Bashari bin Zawdin, Izzat Iskandar Aiman bin Muhammad Yunus, and me myself Ahmad Abu Hanifah bin Adnan. We go to the contents of this experiment, which consists of the introduction, followed by the basic concept, methods and design of experiments, analysis and interpretation of result, development of model, discussion of results, and finally conclusion. We go to the introduction of the experiment, which includes the problem statement, the objective of the experiment, and also the relevant and validated source. The problem statement of this experiment is how we determine and analyze the downstream and upstream depths with respect to the hydraulic jump. Next, problem statement is how we measure and calculate the energy dissipated in the hydraulic jump. And the final problem statement in this experiment is how we measure and calculate the power loss, particularly at the hydraulic jump, based on the specific energy consideration. Meanwhile, the objective of the experiment is to analyze the properties of a hydraulic jump generated when the flow of water is below the switch gate. Another objective of the experiment is to study the patterns of flow acquired when flow of water is below the switch gate. So, in order to overcome the problem statement and to achieve the objective of the experiment, we have utilized some relevant and validated source in order to conduct this experiment and also to analyze the finding of this experiment. The LMNO engineering have been utilized in order to understand about the hydraulic jump in horizontal rectangular channel. The engineering notes has been utilized in order to understand about the hydraulic jump formula, hydraulic jump for rectangular and triangular channel, and also the hydraulic jump table. The Khulna University has been utilized in order to give understanding about the flow beneath a sluice gate. The University Tun Hossain on Malaysia Department of Water Resource and Environmental Engineering have been utilized in order to give the understanding about the properties of flow beneath the sluice gate. And the MDPI, which is the popular publisher of open access scientific journals, has been utilized in order to give us understanding about the jump and energy dissipation with sluice gate. Okay, I will pass the presentation to the next presenter.
Next, we move to the basic concept. A hydraulic jump occurs when a supercritical flow changes to a subcritical flow. In such cases, the elevation of the water surface increases suddenly in the direction of flow. The violent motions of flow are accompanied by a significant loss of energy head through the jump. It is an important phenomenon associated with the dissipation of energy in flows over dams, weirs, and other hydraulic structures. The strength of the jump depends on the Froude number of the flow entering the jump. Figure 1 shows an experimental setup which consists of a rectangular flume and a sluice gate at the upstream part of hydraulic jump. The type of jump is characterized by the Froude number Fn at n sections of rectangular flume, which is defined as follows: Fn equal to Vn over square root of Ghn equal to Q over Bhn square root of Ghn. It will be found that the jump is characterized by a strong dissipative action. The specific energy upstream and downstream of the jump is calculated as follows: E equal to H plus V squared over 2G. The energy dissipated in the jump is given by Em equal to E1 minus E2. The power loss due to the jump in the rectangular flume can be estimated by PL equal to rho GQEm. The conditions which generate hydraulic jump are F1 greater or equal to 1.7 or F2 greater or equal to 0.6, where F1 and F2 represent the Froude number of the upstream and downstream flow respectively. Apparatus for this experiment are rectangular flume, sluice gate, tailgates, and point gauges.
First, we measure the width of the flow channel. We measure the height of the sluice gate.
On the power supply. Next, we open the valve to start the water to flow in the flume.
We close the hydraulic flash to regulate the flow rate of the water. Next, we measure the discharge of the water by measuring the time taken for the flow meter to reach 5 liters using the stopwatch. After that, we place the tailgate at the rectangular flow channel.
Then we measure the height of the water before the sluice gate. And we record the data.
After the jump stabilized, we need to find the depth of the upstream and the downstream using the pump brush. Next, we measure the height of the upstream. We place the point brush right after the water surface, and then we record the data at the point brush. Next, we measure the height of downstream right after the hydraulic jump using this point brush. We place the point brush right after the water surface, and then we take the measure and record. Next, we repeat the procedure by taking the different discharge and also different height of sluice gate. Hello, in this part, I would like to explain our result of our experiment of hydraulic jump. This is the table that includes the data that has been recorded from the experiment. We got height of sluice gate in mm, volume in liter, time taken in second, height before the sluice gate H, upstream depth H1, and also downstream depth H2. In this experiment, the manipulated variable is height of sluice gate, which have three different types, which is 2 mm, 5 mm, and also 8 mm. And other manipulated variable is the discharge of the water flow in the rectangular flume. And then the response variable that need to be recorded during the experiment is the height before the sluice gate, upstream depth H1, and also downstream depth H2. Next, in this slide shows us the relationship between the height of sluice gate and also the depth of water at the upstream, which is indicate the blue one, and also the downstream H2 indicate the orange one. We can see the trend that the depth of water at the downstream is higher if compared to the upstream H1. In this experiment, we need to find the velocity at upstream and downstream, specific energy, energy dissipated, power loss, and also Froude number. The first step in this analysis, we need to find the discharge of the water first. From the experiment, we got the discharge of the water in unit liter per second, so we need to change it. So we take the experiment data number 1, which is the 0.389, and divide it by 1000. From that, we can get the value of discharge of the water 0.000389 in unit meter cube per second. After that, we can find the upstream velocity V1 and also downstream velocity V2 from the discharge that we got from previous calculation. Let us move to sample calculation. Using the formula discharge is equal to velocity times area, we can arrange it and find the velocity by dividing the discharge of the water by that depth of upstream H1 and width of rectangular flume, and then we can got the upstream velocity V1, which is 1.62 meter per second. Next, in this slide, we can see two bar chart. The first bar chart indicate the relationship between upstream velocity vs 3 different height of sluice gate, while bar chart 2 shows the relationship between downstream velocity V2 vs 3 different height of sluice gate. Next, the third step is we need to find Froude number Fn. We need to find Froude number at upstream F1 and also Froude number at downstream F2. In this sample calculation, we use experiment data number 1. As we can see, the formula for Froude number is velocity at upstream divided by square root of g, which is the gravity, and times with upstream depth, which is h1, and we inserting the value that we have got from the previous calculation, and we got the Froude number at upstream for data number 1 is 9.44. Next, in this slide shows us the relationship between the height of sluice gate vs the Froude number at upstream F1, which is in the blue bar, and also the orange color indicate the Froude number at the downstream. And we can see in this bar chart the trend, which is the Froude number at upstream F1 is higher than Froude number at downstream F2. Next, we need to classify the type or categories for the particular hydraulic jump. As you can see in this table, indicate the various categories of hydraulic jump. Let's we take an example from experiment data number 1. The Froude number at upstream F1 is 9.44, which is its behavior of hydraulic jump is A strong jump that is rough but still perform well. Next, we take experiment data number 5. The Froude number at upstream F1 is 4.32, which is fall under category an unstable escalating jump. This can cause wave that can travel for miles downstream. Next, step number 5 is find upstream specific energy E1 in meter and also downstream specific energy E2 in meter. With that value, we can find the energy dissipated EM. Next, we move to sample calculation. First, we need to find upstream specific energy E1 using this formula. This formula is H1, which is upstream depth, plus with upstream velocity V1 square and divide by 2 times gravity, and we got this answer, which is 0.1368 meter. Next, we move to finding the downstream specific energy E2 using the same formula, but we need to change to downstream depth and also downstream velocity, and we got this answer 0.0372. To find energy dissipated EM, we need to subtract these two value, which is 0.1368 subtract with 0.0372, and we got the energy dissipated 0.0995 meter. In this slide indicates the bar chart, which is have data of energy dissipated EM in meter, which is we have calculated in the previous slide, VS with 3 different height of sluice gate, which is 2 mm, 5 mm, also 8 mm. The last step in this analysis is step number 6, which is find power loss PL in unit watt. We use experiment data number 1 to find the power loss as the sample calculation. We use this equation to find power loss, which is density times gravity times discharge and times the energy dissipated. The density of the fluid, which is the water, is 1000 times 9.81 and times its discharge, which is 0.000389, and the energy dissipated 0.0995, and the power loss that we got is 0.3797 watt. This is the last part of analysis, indicate the bar chart of power loss PL in unit watt vs the 3 different height of sluice gate.
In open channel, transition from supercritical to subcritical flow called as hydraulic jump. Froude number is associated with the change of the water depth and discharge in open channel. In this experiment, we will make a discussion about the data and analysis that we obtained from this experiment. Based on the results and analysis that we have done in analysis part, there are few data that we collect from the experiment. It is height of sluice gate, volume of water, time, height before the sluice gate, upstream depth and downstream depth. All of these data are very important to make the analysis for this experiment. For the example, to find the discharge, we can find it with divide the volume of water with time. From the bar chart upstream velocity versus height of sluice gate, we can see that the lower the height of sluice gate, the greater the value of velocity of the water, while in downstream velocity versus height of sluice gate bar chart, we can see that the lower the value height of sluice gate, the lower the value of velocity. Apart from that, based on the energy dissipate versus height of sluice gates bar chart, we can see that low the height of sluice gate will give the height of energy dissipate. Moreover, for the bar chart depth of the upstream and downstream versus height of sluice gate, it shows that the depth of downstream is higher than upstream in all height of sluice gate. Not only that, the bar chart power loss versus height of sluice gate show that the higher the power loss, the lower the height of sluice gate. Lastly, the bar chart of the Froude number at upstream and downstream versus height of sluice gate show that the Froude number at the upstream is higher than Froude number at the downstream, and at the lowest height of the sluice gate for the Froude number at upstream, it showed the highest Froude number. It is occur because behavior of hydraulic jump is a strong jump. In addition, it illustrates that upstream depth increase as the downstream depth also increase at the constant discharge and different height of sluice gate, whereas an increment in the downstream depth is obtained as the discharge increase at constant upstream depth. Froude number at the upstream depth boost as upstream depth decline that can be attributed to the increase in flow velocity. On the other hand, an increment in the upstream Froude number is achieved by increasing the flow discharge at upstream depth. Moreover, a significant increase in flood number is recognized as a result of mirror increment in the upstream depth compared to the change in flow discharge that can lead the bad scoring. Next, recommendation for avoid error in this experiment is take the reading more than one time to get the average value. As example, it can avoid the error when taking the reading of depth in millimeter. Besides, make sure there are no leaking from the fluid to avoid instrumental error. Lastly, make sure operate the sluice gate with careful to avoid error. To avoid error occur in operation of the sluice gate. The application of hydraulic jump in the civil engineering field is most commonly used choice of design engineer for energy dissipation below spillways and outlet. A proper design hydraulic jump can provide for 60 to 70% energy dissipation of the energy in the basin itself, limiting the damage to the structure and the streambed. Besides, hydraulic jump also to maintain the high water level on the downstream side. This high water level can be used for irrigation purpose. Lastly, the hydraulic jump can be used to remove the air from the water supply and sewage lines to prevent the air locking.
Okay, finally we'll go into the conclusion of this experiment, which is, from the analysis, it is crystal clear that the magnitude of flood number for upstream is larger than 1, and for downstream the magnitude is lesser than 1. Hence, this condition will cause the hydraulic jump to occur. But what is the advantages of the hydraulic jump? Some of the advantages of the hydraulic jump are it include energy dissipation both in dams and channels. It's also scouring prevention in the downstream part of the dam, and also reversing the flow of water and high water level on the downstream side. So, all in all, it is crystal clear that we have successfully achieved the objectives of the experiment, which is to analyze the properties of hydraulic jump generated when the flow water is below the sluice gate, and also to study the patterns of flow acquired when the flow of water is below the sluice gate. So, that's all from our group for our presentation about the hydraulic jump. Thank you.